In this box right here, I have a set of 5 different springs, all of equal length, but each one with a different stiffness. So if I grab and pull on them, some of them require a greater amount of force to stretch, some of them require less. You can't really see it, but I can definitely feel it. So the question is whether or not this spring represents an ideal spring. Well, here's the case. If it indeed is an ideal spring, then its behavior would be something like this. For me to stretch it 1 inch requires a certain amount of force exerted by my hands. Okay, so that force is in my hands right now, right? I'm exerting an effort. I'm not doing any more work. I did work to stretch it that 1 inch, but I don't continue to do work to hold it there, even though I'm exerting a force. Now I stretch it so that the overall stretch in the spring increases twice as much, up to 2 inches. Now how much force am I exerting with my hands? Well, if this is really an ideal spring, twice as much force. What if I want to stretch it 3 inches? 3 times the force. So the farther and farther I stretch it, the greater the force I have to apply, and it eventually reaches a point where it's hard for me to stretch it any further. So there's a linear increase in the amount of force applied as the amount of stretch goes up. There's a law for that. It's known as Hooke's law, and you'll learn more about that in the next video lesson.